Hello there, my name is Sameeh Olipani, and I am a third-year Mechatronics student. For this video, I'm presenting my final project on the data that I collected with the provided accelerometer. The purpose of collecting the position and acceleration data is to understand the dynamics on how things move and the forces that are applied to it, such as the accelerometer. What I want to demonstrate is the relationship between acceleration and velocity. And the way I'll go on about this is recording the acceleration of my car. The materials that I used to collect the data was a BNO 055 absolute orientation sensor and an Arduino Uno. The data is in the form of comma-separated values, or CSVs for short. The CSV data was fed into a MATLAB program that was developed for our class, which visualizes the data. I let the Arduino sit in the passenger seat of my car while it was running, as it was a simple way to keep the Arduino safe without taking on the use of a case. If you may not already know, the relationship with acceleration and velocity is that acceleration is the rate of change in velocity, meaning that the change of one instance of velocity to another is the acceleration of the body as a whole. If we look at this graph with the parabola being a function of distance over time, the acceleration is the rate of change at the instantaneous point of time. So going back to my car, we notice that the acceleration is constant while the car increases in velocity. Here's the idea in action. Note that the peaks and valleys of the data is an error of the data collection with the Arduino. As you can see, the car starts from rest and reaches the max speed of the road. We notice that the acceleration remains constant through the peaks. There is a slight error in the data though, as the accelerometer only collects data once every 15 milliseconds. What I would have done differently in the future is that I would collect data over a vast amount of time, as not only driving is relaxing, but it would be interesting to see the acceleration and position data over time and compare it with its accuracy. This is what most navigation systems would use as an inertial navigation device. Thank you for watching my presentation.